Good morning, boys and girls. Happy Tuesday. Today is NTI day 27. We are continuing our Module 3 review, and we are working on adding and subtracting fractions today. And so we're going to use what we talked about with equivalent fractions yesterday. We're going to use that knowledge to add and subtract fractions, okay? And so we're going to start out with 1/5 plus 1/2. And something I always talk about with my class is, I have a problem. Let's, say Maddie walks in with 1/5 of a pizza. Lila walks in with half of a pizza. And I want to know how much pizza we have all together. Well, I have a problem. And the problem is that Maddie's pizza was cut into fifths while Lila's pizza was cut into halves. And so we need that pizza, not these pizza, the pizzas, well, two of them, yeah, needs to be cut into the same amount. For example, both pizzas need to be cut into fifths, or both pizzas need to be cut into halves, or both pizzas need to be cut into fourths or tenths, or whatever it may be, so that we can figure out how many slices of how many equal parts, okay, are all together. And so what we're going to do is yesterday we learned that we can multiply a numerator and a denominator. We didn't learn, we reviewed, by the same number to get an equivalent fraction. And so that's your goal. You're trying to get both pizzas cut into the same amount of equal parts. And so, what my class does, some of us can do this in our head, and that's okay. And some of us need to just write down a couple of ideas. And so, what my class does is we count by fives and we count by twos to try and get a denominator that's going to be the same. Because when you get that denominator the same, your pizza is going to be cut into the same parts. Okay. So we're going to count by fives, and I always tell them to go like four. Count about 4 times. So 5, 10, 15. 20. Okay, and then we're going to go with our 2. So 2, 4, 6, 8. And I'm still not even close to the 20, so I'm going to keep going with my 2s. It's obviously a less number, 10. Oh, and then I'm already figuring out that we have a common denominator. We are able to cut this pizza into the same amount of equal parts, and it's going to be tenths. So Maddie's pizza, we're going to try to, instead of saying she has 1/5 of a pizza left, or she brought into the classroom 1/5 of a pizza, we're going to try and say that it's something out of 10 pieces instead of just 5. So we're going to have a new denominator. Oops, redo that. Sorry about that. Our equivalent fractions. We're going to create equivalent fractions here because we want to have the same amount of pizza, right? And same for the half. So instead of Lila's pizza being originally cut into halves, we're going to cut hers mentally into tenths. Okay. So just like we learned yesterday, now my class was able to use these down here. What are we going to multiply 1/5 by to get an equivalent? That's a multiplication symbol, sorry. To get an equivalent fraction that has a specific denominator of 10. And this is my notes up here. When adding or subtracting fractions, we need equal parts or a common denominator where we use our knowledge of equivalent fractions. So this time, yesterday, you got to pick any number you wanted to find an equivalent fraction. Today, you're multiplying by a specific number that will get you a specific denominator because you want whatever you're working with cut into the same amount of equal parts. So what am I going to multiply 1 by and 5 by to get a fraction that's equivalent that has a denominator of 10? Well, you can always go down here. And my class would do this. They would say, well, how many times did I count by fives to get to 10? 1, 2. So we're going to multiply 1/5 by 2 halves because it's equal to a whole. And 1 times 2 is 2, and 5 times 2 is really already there. It's 10. So 1/5 is equivalent to 2/10. So instead of saying Maddie brought 1/5 pizza to our class, Maddie brought 2/10 pizza to our class. Guys, best part, they're equivalent. They're the exact same amount of pizza. We're just trying to get them both in tenths so we can add how many pieces out of 10 are left or still there. Okay. All right, let's do it to Lila's fraction. So Lila had half a pizza, and we can go down here to our 2s. We're trying to ask ourselves, what are we going to multiply this numerator and this denominator by? Well, you can go down to your 2s here. How many 2s did it take to get to 10? 1, 2, 3, 4, 5. So we can multiply by 5/5, or multiply the numerator by 5 and the denominator by 5. 1 times 5 is 5. 2 times 5 is 10. So now look what you notice. So Maddie brought 2/10 pizza. Lila brought 5/10 pizza to our class. How much pizza is there altogether? So out of 10 pieces, how many? Yes, 7. Out of each person's pizza was cut into tenths, so 7/10. And then yesterday we learned about simplifying. So I would ask my class, can I count by any number that would get me both to 7 and 10? And no, there is not. 7 is a prime number, which means you can only multiply by 1 and 7, 1 times 7 to get to 7. And 10 has other factors, but 7 is a prime number. So this would have to be a 14 down here, or a 21, or a multiple of 7, and 10 is not. So 7/10 is the answer for 1/5 plus 1/2. Okay. All right. I want you to write down the next problem. I want you to write down 2/3 plus 4/5. I want you to pause the video, and I want you to see if you can solve, because remember, we've done this before. We're just reviewing. So I want you to pause the video, and I want you to see if you can add 2/3 plus 4/5 and see if we get the same answer. Okay. All right. You pause. Go ahead. And then you work in your notebook, and we'll get back. Press play whenever you're ready. Okay, so now that you've had a minute to solve 2/3 plus 4/5, we're going to talk about it as a class. So 2/3 plus 4/5, and so we have a problem, don't we? Let's say let's just use pizza again, or a cake. Lila. Well, I'll use different people this time. So I'll use some people from Miss Malay's class. So Trevor has 2/3 of a pizza, and Jackson Pierce has 4/5 of a pizza. And we want to know how much pizza they have all together. And so if we were going to count, Trevor has 2 out of 3 pieces, while Jackson Pearson has 4 out of 5 pieces. And so we have a problem. We need our pizzas cut into the same amounts. And so what we can do is we can use those denominators, and we're going to try and find a specific denominator. So we can count by 3s and count by 5s. And some of us might already be able to know in our head, is there a number I can count by 3s and 5s? And what would be the same number it would end at? Oh, I got it. And you row. Some people might need this down here. So remember, I'm going to count by 3s. 3, 6, 9, 12. And I usually have my people do about 4. So 5, 10, 15, and then 20. So I have a little bit of a problem there because I still don't have a common denominator. And there we go. And I need to move back up to my 3s because my 20 is greater than my other numbers. So I'm going to keep counting up here. So counting by 3s, 15. Oh, and there it is. All I do is count by 1 more. And so we have found a common denominator. So now Trevor and Jackson's pizzas, instead of Trevor's being cut into thirds and Jackson's being cut into fifths, we can now cut them into 15ths. Pretty cool. So what we're going to do is we're going to have a new pizza, not a new pizza. We're going to use their pizza, and we're mentally going to cut them into 15ths instead of thirds and fifths. And remember, using equivalent fractions, we got to multiply the numerator and the denominator by the same number. So if I go down here in my 3s, how many 3s did it take to get to 15? 1, 2, 3, 4, 5. So we're going to multiply this by 5/5, or numerator by 5, denominator by 5. 2 times 5 is 10, and 3 times 5 we already know because down here is 15. And then we have 4/5. So we're going to, how many 5s did it take to get to 15? 1, 2, 3. So we're going to multiply this to create an equivalent fraction with a denominator of 15. We already have it written down there. We're going to multiply by 3/3. 4 times 3 is 12, and 5 times 3 is already 15. So now their pizzas are cut, and we can just add their slices of pizza left. So 10 plus 12 is 22, and our denominator is if we're counting when we add fractions, we're counting the shaded, or the amounts of pizza, and how many equal parts were in each whole. And so it would still be 15. We do not add denominators. 22, if we added that, it'd be 22 out of 30. That means someone pizza would have been cut into 30 equal parts, and we did not cut a pizza into 30ths. We cut each pizza into 15ths. That's why the denominator stays the same. So if you got to this point a while ago, you might be like, Miss Crazy, something's going on. And yes, you are correct. We have a problem here. So we don't have a problem, but we're not finished. And so what's going to have to happen is, what do we end up with? My class talks about, we have 2 names for this type of fraction right here. So this is not our final answer. So the two names for this fraction, if you just said them, one is an improper fraction and one is a fraction greater than one, a whole. And so we can't leave this like this. So our strategy is to divide. And actually tomorrow when we're going to talk about this tomorrow with improper fractions and writing fractions as division and division as fractions. So I'm excited about that tomorrow. So we've already practiced log division as well. And so we're going to ask ourselves, how many times can I count by 15 to get to 2 without going over? Well, if I count by 15, 15 times 1 is 15. I'm already over. So how many times can I count by 15 to get to 22? I think we all can probably sort of figure that out. 15 times 1, we already know is 15. And so if we try 15 times 2, if I double 15, 2 times 5 is 10. And 2 times 1 is 2, plus 1 is 3, and we actually go over 22. So it's going to be 1, and we're going to subtract. So 22 minus 15, 2 minus 5 is negative 3. That's not what we're looking for here. You're not in that math world yet. We need to borrow. Borrow 1, give 10. So we have 12 minus 5 is 7, and 1 minus 1 is 0. We have 1 remainder 7. Now, we're not going to write that here. That's not what we're writing. That is not an answer that we're looking for, and you all should know that from your math class this year. We're not looking for 1 remainder 7. Oh, we have 1 remainder 7 pieces of pizza. No, that doesn't make any sense. We need to write this as a mixed number. So here's your whole. Your remainder becomes your numerator, and you might be surprised. Yeah, your denominator, what you're dividing by, is how many equal parts of the pizza still stays. So we have 1 and 7/15. In my class, practiced that a lot this year. 1 and 7/15. 1 and 7/15. We said it over and over and over. So how much pizza do Trevor and Jackson have all together? They have 1 and 7/15 pieces of pizza or pizza. Okay. All right, let's move on to some subtraction. So I'm going to put 1 and 7/15 there. And that's a space there, not 17/15. That's 1. I can even put the word and if I want. 1 and 7/15. All right, let's move on. So pause your video. Let's move on to subtraction. So you have 5/8 minus 1/4 now. So go ahead and write down 5/8 minus 1/4. And I want you to remember, if you have eighths and you're taking away fourths, something's not right there. You've got to create equal parts, common denominators. You cannot subtract those if they don't have equal parts. So I want you to pause the video, write that down, and then go ahead and try to solve that, okay? All right, I'm going to leave all that there now that you're back, and I'm just going to put it up here. So we have 5/8 minus 1/4. And so we need to create equal parts. And so we're going to go down. We're going to count by 8, 8, 16. I mean, I left myself enough space there. Sorry about that. Let me fix that. I want to be able to write my equivalent fractions right below it. So we have 8, 16. Now, 4s are really small numbers, so I'm just going to go a couple there. So 4, and I only have to go a couple, and I already found what I was looking for. And so we know that now, let's use Miss Horn's class. So let's say Avea brings 5/8 of a birthday cake to school, which can't make cake to school, but anyways, and the class eats 1/4, and I mean, we'll make this a big old cake, and the class eats 1/4 of it, how much cake is left? And so if I'm taking 1/4 from 5/8, I've got to the cake has to be cut into equal parts. If I cut the pizza into eighths originally and I'm taking away something, I've got to be in eighths, okay? And so it's going to be an 8. So, and if you notice, the 5/8 already has a denominator of 8, so it actually gets to just stay the same. And it's our 1/4 that needs to be written as eighths. So we're going to ask ourselves, how many 4s did it take to get to the 8? 1, 2. So we know to find an equivalent fraction for 1/4 that has a denominator of 8, we're going to multiply by 2 halves. 1 times 2 is 2, and 4 times 2 is 8. And then we can subtract. 5 minus 2 is 3, and we know that our cake, was cut into eighths. Okay, and so we end up with 3/8. And then I would ask my students, can that be simplified? And we need to ask ourselves, is there any number I can count by that would get to both 3 and 8? And there's not, because, and 3 is a prime number here. So unless this excuse me, unless this is a multiple of 3, like 9 or 6, 9, 12, 15, 18, we wouldn't be able to simplify. And so the answer to that problem is 3/8. Okay? Let's see if it does it for everyone. No. Excuse me. All right. All right. So I want you to write down the next one. Write down 1 1/3 minus 1/2. Now, this is going to be a challenge problem before you, so you're really going to have to think here, and I'll tell you where people have the most errors whenever I show you what I think your answer might be because you made an error, or those people who can remember for Module 3 that something a little tricky is going to be coming up in this problem. So write down 1 1/3 minus 1/2 in your notebook and try to solve, okay? All right, so now that you've tried to solve, I want you to watch as I try to solve. I'm going to write down 1 1/3, and I still have my old work over there, but that's okay. 1 1/3, and we are going to subtract 1/2. And so immediately, we know we don't have equivalent parts there. We could use pizza again. I'll just use teachers this time. So let's say Miss Malay brings her favorite pizza to school for lunch, and Miss Long and Miss Kelly and Miss Horn and myself and Miss Malay, we eat 1/2 of that. How much pizza is left? And so if her pizzas were cut into thirds, we need to make sure that we're taking away something that's equivalent to a third. So we're going to count by 3s and 2s. So we have 3, 6, 9, 12, and then we have 2, 4, 6. And then we stop right there because I see that I have an equivalent fraction. We can cut her pizza, instead of saying she had 1 1/3 pizza, we can use 6. And now something that I tell my students to do is that not to forget is don't forget your whole. Don't leave that whole just sitting up there. So we're going to create equivalent fractions with 6. Okay, so we want the original pizza and mentally to be cut into 6th, and we want to take away pizza that was into 6th. Okay, and so remember, using our equivalent fractions, we can multiply numerator and denominator by the same number or by a fraction equal to 1. So how many 3s did it take to get to 6? 1, 2. So we're going to multiply by multiplying essentially by 2 halves. So our whole number keeps its equal part. 1 times 2 is 2, and 3 times 2 is 6. And now let's go to our 1/2. And so some people are like, Miss Grigsby, I know what 1 is half of 2, what is half of 6, but let's show. So how many 2s did it take to get to 6? 1, 2, 3. So we're going to multiply by, essentially by 3/3. Sorry, it looks like a Y. Sorry about that. All right, so 1 times 3 is 3, and 2 times 3 is 6 down here. All right, so now so we got 1 minus, no holes there would be a 1, and 2 minus 3, 2 minus 3. So 2 minus 3 would actually be -1. Again, you're not in that math world yet. And so we've got a problem here. We have a numerator not great enough to subtract the next one. So I want you to pause and think. And remember, you solved. And so if you wrote, here's where the mistake is. 1 minus no holes equals 1. 2 minus 3 is 1. And 6. Yeah, that's not correct. 2 minus 3 is not 1. You have made an error if you wrote 1 1/6. So I want you to think. Pause and think. All right, so what do you think we're going to have to do? What do we need? Yeah, it's almost like borrow. It's tell my class in subtraction when you don't have enough. When you have a number on the top of your vertical subtraction problem and you don't have enough, you can borrow from elsewhere. Use tens, hundreds, or thousands, and move them into groups of tens over. And so in this case, you can do that here. We can borrow this one from the whole. Excuse me. And so I had to ask my students, what is this whole worth? What is it worth? If I was drawing these pizzas here, this one whole pizza and 2/6, 1 and 2/6, what would you have cut that first pizza into? You have 2 shaded out of 6 here. What would have this been cut into and all shaded? Yes, 6. So if all the parts are shaded, this whole is worth 6/6. So we're going to use that 6/6. You can always use the denominator, guys. It tells you what the pizzas get into. Remember, that was our equivalent. That was our equal part. So 6/6, and we're going to almost like subtract, actually like in our regrouping, we're going to use that 6/6 and we're going to give it to the 2/6 because we want that numerator great enough to subtract that 3. So, oh, there should have been a space there. Sorry about that. It's probably going to be too big, but that's okay. All right. That's pretty good. Not too bad. Okay, so 6/6 plus 2/6 equals, we're going to mark that out, 8/6. So instead of saying 1 and 2/6, we can say its equivalent improper fraction, which is 8/6. Now, if I were to prove that to you, oh, that is not going to be big enough because you know I am not going to be able to draw this very well. Y'all going to have to just stick it with me, okay? Just stick with me. All right, so I'm going to try and draw 1, 2 pizzas, and I have, whoa, Nelly. So I'm going to be drawing 1 and 2/6 pizzas. And so I'm just going to use my, sorry, it's not going to be great, but I'm trying my best. So I'm showing 1 and 2/6 pizzas, okay? So we know that our whole first one is all shaded because it's a whole, okay? So all shaded, all of it, right? And then over here, we only have 2/6 shaded. Okay, so this is your proof. This is your why. So instead of saying 1 and 2/6, all right, let me write that down. Instead of saying 1 and 2/6, we could also say, count 1, 2, 3, 4, 5, 6, 7, 8. 8 out of how many equal parts in each whole? 6. See, they're equivalent. Okay, so that's really the why. And so in this case, we don't have any more holes, or we don't have a hole there to subtract another one. So now we have 8 minus 3, which is 5, and our denominator is still equal parts 6. Okay, and that would be your answer, 5/6. All right, that's all I have for you today, guys. If you have trouble on the at home on your equivalent or on your add and subtractions packet, go back to the video, rewatch. If you have trouble on your Google form, if you're working through Google Classroom, go back and watch the video again. Okay. I hope you have a great day, and I will see you tomorrow. If you have any questions, just holler at your teacher. Bye, guys.